Welcome back to another video. So in this lesson, we're going to be looking at drawing a vector diagram. So a vector diagram is important. You really need to know how to do this because it's the first thing that you need to do when you are trying to get your resultant velocity or your relative velocity. So the first thing that you need to know is obviously your directions. Okay, you need to know this. You have your north, east, south, and west. If you don't know this, it will be very difficult for you to draw your vector diagrams. So to help you maybe remember, if you have trouble remembering these directions, just use the trick that I used to use is never eat silk worms. So you can use that if you like or whatever works for you. So that's the first thing that you need to do. The second thing that you need to do is that you need to understand the bearing convention. So for example, if you are told that an aircraft is traveling 24 degrees from north to east, what that means is that you're going to end up with a vector that is going, this is just a sketch, so don't mind the degrees on my ruler there. So there's my vector, and then this will be my 24 degrees as I'm going from north to east. Please don't get confused here, because if you take that angle to be from east to north, then your vector diagram will be wrong. Okay, so let's look at an example here. I took this question from one of the past papers. You have an aircraft with an airspeed of 330 kilometers per hour, which takes off from OR Tambo International Airport in the direction 35 degrees from north to west. The aircraft is blown off course by a wind of 90 kilometers per hour from the direction 42 degrees from west to south. Alright, so let's draw a vector diagram for that question. Alright, I'm going to start with my directions just so you guys can see exactly what I'm doing. So there's my east, that's south, that's west, and that's north. The first vector, that is the vector for the aircraft, is going at 35 degrees from north to west. So that will be that angle over there. Just drawing that vector from the origin. Alright, so that's my first vector, which is 35 degrees from north to west. And then my second vector is the vector of my wind, which is going from west to south. So from west to south, that's what you end up with. And it's going from west to south, so that's why you see my arrow pointing towards the origin. So this will be 42 degrees. Alright, so I'm gonna quickly label my vectors. This is the velocity for the wind, and then this is the velocity for the aircraft. So the last thing that you need to do then is get your resultant vector, for which you don't know what it is and you're asked to calculate. So your resultant vector is just a matter of joining your two vectors. So this will call it VR for resultant velocity. Alright, velocity is a vector. So don't get confused when I refer to it as vector or velocity is the same thing. In this case, we're dealing with velocity. Alright, so now you have completed your vector diagram. The last thing you're going to need to do is you're going to need to calculate at least one angle of the triangle that you've drawn out. You will essentially realize that your vector diagram is a triangle. That's why we use trigonometric identities and formulas to solve for the vectors and the direction. So you would calculate that angle because you are given the directions of the two vectors. So that angle, that is the angle of the triangle, that is from here all the way to here. You will find that that angle is 97 degrees. All right, so at this point I take it you understand how I got to 97 degrees, but please, if you don't understand, let me know in the comment section below so I can do a separate video just for that. So we are not going to be doing any calculations in this video. We will continue with that in the next video, where we will be calculating the resultant velocity and the relative velocity. This video was for you to just make sure you understand how to draw a vector diagram. So I'll see you in the next video.